Question from May-June 2020, paper 13, question 34. Two copper wires are joined together and carry a current as shown. Wire P has diameter D and wire Q has diameter 2D. What is the ratio between the average drift speed of free electrons in wire P over wire Q? The only formula that involved drift velocity is this. Current is equal to number of free electrons per volume, the cross-sectional area, the drift velocity, and the charge of an electron. Rearranging the formula in terms of the drift velocity, now we have the current over the number of free electrons per volume times the cross-sectional area times the charge of an electron. By the way, I fixed my V, was lowercase v. This is now uppercase V, which is the same here. So V in this case is the drift speed or drift velocity. So on the numerator, I have I over NAE, all these for P. And on the denominator, I have I over NAE for Q. Now let me see what I have in common so I can cancel in this fraction here. Current is the same. I is the same for both wires. And both wires are made of the same material. So which means this N is the same. The number of free electrons per volume. And the charge of electron, E, is also the same. E is the same. Because of that, I and E is the same on both wires. I'm going to cancel here. So I is the same, N is the same, and E is the same. What is left here? On the numerator, I have 1 over AP, and on the denominator, I have 1 over AQ. Rearranging a little bit more, so on the numerator is 1 over AP times, I have this fraction, now I have to flip, so I have AQ. Assuming that both cross-sectional area is a circular shape, so the area of a circle in terms of the diameter is pi over 4 d squared. Okay, so now I have the ratio between both drift velocity. I have the area of Q, which is this, over the area of P, which is this. So, because I'm going to cancel pi over 4 on the numerator and denominator, I'm not going to include in this step just the diameter. So that will be the dq squared over dp squared. So the diameter of Q, the problem says 2d, so 2d squared over the diameter of P is just d squared. So this is 4d squared over d squared. So I'm going to cancel this, and the final answer is 4. So this should be answer D. Question from May-June 2015, paper 13, question 34 and 35. I'm going to start with question 34. A simple circuit is formed by connecting a resistor of resistance R between the terminals of a battery of electromotive force, EMF, of 9 volts and constant internal resistance R. A charge of 6 coulombs flows through the resistor in a time of 2 minutes, causing it to dissipate 48 joules of thermal energy. What is the internal resistance R of the battery? First, let me find the current using the charge and the time provided that is flowing through the resistor R. Since both resistors, they are in series, so the current flowing through R is the same current flowing through small r. So the charge is 6 coulombs and the time is 2 minutes. I want in seconds, so the current is 0.05 amps. To find the value of R, I have the current flowing through R, this internal resistance, but I do not have the voltage across this resistor. I can find the voltage across this resistor using the energy provided, which is 48 joules. So the energy provided is 48 joules that is dissipated in this resistor. So the formula for, one of the formulas for voltage is energy over charge. So I have this energy, I have this charge, and the voltage across this resistor is 8 volts. Because this is a series circuit, so the EMF voltage provided is equal to the voltage drop on the internal resistance plus the voltage drop across these resistors. So this is sub little r and sub large r, which is this one. So I can state that E is 9 volts is equal VR, that I don't know, plus the voltage across the big resistor is 8 volts. So the voltage across the small resistance is 9 minus 8 is 1 volt. Now the last step is to calculate the value of R. Little r is, by Ohm's law, is the voltage across this resistor over the current flowing through this resistor. So here is V is 1 volt and the current flowing through is 0.05 amps. So the value of this small resistor is 20 ohms, which is option C. From the same test, now question 35, a source of EMF 9 millivolts has an internal resistance of 6 ohms. It's connected across a galvanometer of resistance 30 ohms. What is the current in the galvanometer? A galvanometer is an instrument that measures small current. Galvanometers must be connected in series with the circuit. So here is a sketch of the circuit. So the EMF with its internal resistance, so it's like a cell, or a battery with its internal resistance, and this is the current flowing here. So what we need to do here is to find the current of this system. So because this is a series circuit, so the voltage supply here is going to divide the energy between this small resistor and the galvanometer. So 9 millivolts is going to be equal to the voltage drop on the small resistance plus the voltage drop on the galvanometer. So the voltage is current times resistance. So here we have, so we can now calculate the current. So I times 36. So I is 9 millivolts over 36 ohms. And my result is 0.25 milliamps. Look at my options here. I do not have this option. but I have this one, 250 microamps. So let's see how these work out. So I is equal, if I move my decimal 1, 2, 3, and I make 250 times 10 to the minus 3 times milli is 10 to the minus 3 amps. So my I is 250 times 10 to the minus 6 amps, and 10 to the minus 6 is microamps. So that's my final answer. A. Question from May, June 2013, paper 12, question 34 and 35. So let me do 34 first. A filament lamp has a resistance of 180 ohms. When the current is 500 milliamps, what is the power transformed in the lamp? So it's provided here current and resistance. So I can use this formula. P is I square R. So my I is 500 times 10 to the minus 3 square times R is 180. So I'm going to use my calculator to get the result. Okay, so this is 500 negative 3 square times 180. 45 watts. Option A. Question 35. Two wires P and Q made of the same material are connected to the same electrical supply, right here. They are in parallel. P has twice the length of Q and 1/3 the diameter of Q, as shown in this diagram. What is the ratio of the current in P over current in Q? First, the formula for current is voltage over resistance. I do not have the resistance, so I need to calculate the resistance using this formula. R is rho L over A, because it's related to the resistance of a wire. Okay, so IP over IQ is V over R. Now my R is rho L over A. All these for P over the same for Q, V over rho L over A, all these for Q. Now I'm going to cancel the same variables, because both wires, they are connected in parallel, so the voltage across each wire is the same. So I'm going to cancel voltage. Another piece of information, it says that both wires are made of the same material. So that means that resistivity is the same. The only variables that are changing here is the length and the cross-sectional area for each wire. So I will keep those values here. So I'm going to rewrite this ugly fraction here. So it is 1 over L over A, all these for P, and 1 over L over A, all these for Q. Okay, so I made a correction here. This actually is L, the length, right? So I'm going to fix this. Here I have a numerator over a fraction. So I'm going to flip this fraction. So I have A over L, all this for the wire P, and the same here on the denominator is A over L for the wire Q. So the next step is to keep my numerator as it is, A over L for P, and now I'm going to flip this fraction here, which is L over A for Q. A side note, I know that A for this circular cross-sectional area is pi over 4 d squared. Pi over 4 is constant for both, so I'm not going to include in this area here because I know that is going to cancel with this one. So to save, for the simplicity of this solution, I'm gonna keep this pi over 4 out. Okay, so now what I have, so A for P is just D. So D squared over the L for P is 2L. And maybe I should do a little bit like this so you guys can see. Again, one more time. I'm working on P, and P is this one right here, this wire. So my A for P is just D squared. And my L for P is 2 times L. Now for Q, my L is just L. And my area, D squared, will be 3D squared. Now I'm gonna go ahead and cancel everything, L with L, D squared with D squared. Don't forget that I need to square the 3. So what is left is, this is 1 over 2 times 9, actually, because 3 squared is 9. This is 18. So my IP, the ratio between the current P over current Q, is 1 over 18. And there will be option D.